Okay ขึ้นปะโอเคมาชัดตัวมาเตะ I'm so excited No have มีครับเป็นสีขาวขึ้นไหมขึ้นแล้วโอเค Alright so good evening everyone. So welcome to my section. First of all, I have some questions to you guys. Do you know these anime or these cartoons? Sorry? Yeah. So anyone know this one? You know that one, right? Anyone know this one? No. Okay, so actually it's quite old. I would say I just realized these things, like couple days ago when I asked some like new generation students and they said, I don't know this one. What's it? So actually these cartoons names in Thai is น้องสาวผมไม่ได้น่ารักขนาดนั้นหรอก In Japanese is Oreno Imotoka Konani Kawaii Wakekanai. So you may think like what is related to something that we're going to say today. So today I'm gonna change this thing to new things because I'm going to talking about like how do we gonna create the RAG AI or LAG AI. So what is LAG, by the way? Yep. So because like I'm gonna base the story from these cartoons. So these cartoons are the main characters. The middle one, the girl one, she is like modern and like really good girl, good student, and very high class, something like that. But actually behind the scene, in her secret life, she loves in anime, playing arcade games. Yep, some like 18 plus games, something like that. And I think what I could help her to achieve something better or easier. So today I'm going to create the RAG AI that will help Kirino to searching anime easier. So, but before we go to that, I would like to talking about like RAG AI first. What is it? So, first of all, forget to introduce myself. By the way, my name is Jirachai Chansivanon. My nickname is Job. I'm currently working at MongoDB in Singapore. So my role is consulting engineer. So normally I gonna work on like how do we gonna make like MongoDB faster? How do we gonna install it? How do we gonna implement it? Something like that. So that's what my work is it. And previously I was working at Microsoft as digital specialist. So you may got confused what is it. So actually it's normally is about like to being like specialized in some Microsoft technology areas. Previously I working as like specialist for Azure about like application things in Azure, how do we gonna install it, how to build it, something like that. But yep, just the past. So last day I'm at MongoDB and I found something like really fantastic thing here as well. So let's move on. So let's start from RAG. Anyone know about RAG before or like know what it stands for? I guess most of you also know about this one. So basically RAG is stand for Retrieval Augmented Generation. So it's going to be one technique to build your applications and connect to LLM, large language model, like GPT, Gemini, or DeepSeek or something else. And let them to find or like searching something for you, but based on human language, like not directly word, something like that. You just like, for example, like you need to searching for sweaters. So if you say, I'm cold right now, so I'm looking for something for wearing to make my body warmer, something like that. You can type in something like this, and your AI can search the sweater or clothes for you. So that will like kind of working for you. But how like works? So normally, like if your applications, right, you have your database here. So normally you interact with your application, like by searching or browsing, something like that. And then your application just search directly from database and return back to you. That's what like something normal application does, right? But for the LAG or RAG, normally it will retrieve the data as the same as like the database does, like normal application does. But they will add something more in this step. It will add augment and generations. What is it? So augment means we're going to use the capability of LLM. It could be your Gemini or whatever, etc. to augment, to combine with their base knowledge. Like if you find some part of the data and you need to add on more to make it more complete. So you can use LLMs to augment it to make it more complete and then generate it back into the human language. So you may probably see something like that with like newer application. Nowadays you can use like ChatGPT and try to search something, and ChatGPT just go to searching from Google or Bing, right? It's Bing actually. So yeah, so searching for you and generate and augment to you, return back to you in the human language to easier way for you. So that's what LAG gonna do. But actually LAG not just only support for normal database. Where is my next slide? Okay, now. So actually one thing that makes LAG more special than the normal searching is it could search from the data that could be PDF, JSON file, images, or something else that you can convert back into the numeric representations like vectors. So that's what we're going to do with LAG today, because normally in those parts it can be on application part, right? Where we're gonna talking about like how do we gonna convert our data and store in something else and make your LM could search easier, because LM doesn't like just go and grab some data and come back, but it needs to searching something that's similar to something that you search, right? So for example, PS3, right? You need to looking for some sweaters or something make you feel warmer, right? So you cannot searching for like warm clothes or something like that from database, but you need to search something and then try to find something similar to your input. So we're gonna talk about like how do we make this process happen on realistic things, because LM will not search like straightforward, but search in some way. So let me switch to this computer instead. I will drawing something to you. Well, I need to move this one. You may think about like why I don't use just only one computer. So actually, I built this demo. I forget to switch the computer. I mean, I picked the wrong one. Yeah, so that's why it ended up like this. So actually, the demo should be on this computer, but in that moment, I picked the wrong one. Well, okay, let me share my screen. Whoa, that's my debug. Okay, so let's start from here. Let me recap what I have said previously. Where is my applications for drawing? Give me a second. All right, it here. Let me reshare my screen. All right. Okay, let me recap what I just explained previously. So normally, right, so you have application, and your application need to search something from database, right? Normally, if you need to search, it will go to search engine instead, right? And just search something that use the keyword, right? But we will not do that one. But we're gonna try to search something as a sentence, right? And we're gonna use LM to convert this one into the numeric representations. Actually, it should be like 1 and 0. And then try to search based on these numbers. So why we need to convert our sentence or search to the numbers? Because number could represent something that like wider or like more dynamics. So because after we convert this one into the numbers, we will search the data based on the number as well. That means the data that we're going to store in the database will store as the number as well. So when we're going to store this kind of data, you need to looking for some database that we call vector database. And then we can use our search engine to search it on the numbers. This is what we are going to do. And today, we will not focus on this part or the part about like generation, but we will focus on this part, how we're going to import the data and how we going to search our data. And today, our components, of course, this database is MongoDB. Because MongoDB is designed to store the JSON format data, right? And it's also optimized for vectors database as well. So that means you can store your data, like the original data, along with the vector data as well. And you can use our search engine we call Atlas Vector Search to search our data. So actually, normally, like this process is quite really complicated, but MongoDB made this thing like more easier. But I'm not sure it's really easier as I'm not sure you're gonna think the same as me. But this process much easier than like previously as well. So let's see what we need to do. Okay. So I will refer to my demonstrations. So in this system, I'm gonna build the application that help Kirilo to search anime easier based on like a human language, right? So that means we need to have the data of anime first. So the first thing I need to do is to load the data somewhere else to MongoDB. So this part I chose to get this one from my anime list web to get the list of animes. And then I do one thing. I convert it to a numbers. So to convert this one to a numbers, how to do this one? I use the LMs. But this LM is embedding model. Basically, embedding model is another like large language model, but it specializes on convert your text into the numbers and represent in like different dimension based on like its chain for. So that means if you have like the background or like synopsis of that anime, it will convert the whole story into the number representations. So in this part, I using just like REST API to get the whole story of my anime and ask my LMs to convert this one into the numbers. And then just insert the numbers along with the full document into MongoDB. This is the first step. So that means after I insert, I will got something like this. Where is it? It's here. Oh, no, this one. So after I insert my data as a numeric representations along with my full data. So of course here is my original data, right? But here I have the synoptic embeddings. This is what I convert by using LMs to convert the whole text of this one, of synoptics, and then convert into the number like this one. So that means this data is ready to search by using vector search. So you're gonna ask, thinking about like, so how do I gonna use vector search? Do I need to create a new vector search engines, or I need to install something else? Luckily, in MongoDB, we already embedded the vector search engine and text search engine for you. But as of now, that engine is already available on cloud versions. But I hope in this year they will be available for you to install on your local machines. So today, I install the cloud version of MongoDB on my computer by using development tools. So that means I don't need to connect to internet at all. So I just create my search index here. Before I came to before my section, I created a search index to tell my MongoDB vector search to know like which field is the vectors type. So I just like create my search index in MongoDB directly. and then just set the type into vectors, and then set the path. So path it means like which field that we going to use as a vector search. So from here, I just say I need to use the gymnastics. I need to copy the whole of data. Yeah. So to do so, in MongoDB Atlas, after you create MongoDB Atlas and it's free, you just create your search index and set the vector search like this. Just choose the path to be the path that you store at the vectors. And then you just set your dimensions, number of dimensions. So how do you identify this one? It's based on your LM's model, which one that you use. So for me, I forgot which one I use for these sections. I use the nomics embed text. So the numbers of dimension is it depends on your models that you choose for. So that means my nomics models, they have 768 dimension. So here I just put this one to be 760 dimensions. To find this one, you can check on the your model documentation. They will tell you that how many dimensions it will return back to you. And next, it's similarities. So similarity basically is going to be like the function in mathematics to help us to searching or matching something that's similar together. So here we have three choices of similarity. We have Euclideans, cosine, and dot products. So you may like, okay, now I have to extend the mathematics class. Actually, if you need to deep understanding of it. But for me today, I'm going to use cosine because cosine is good for finding the something that similar or close together in terms of distance. So I will use the cosine. So to understand the other function, you can check on the MongoDB documentation as well. So I just set this one as cosine. And then change the index name to be something different, like this. And now your database will available for you to search as a vector search. And just that. So to search this one, we just type your sentence. But your sentence as of now is to be string, right? As a human text. So that means we need to convert this one into human text again as well. So if you go to my GitHub, it's gone. My GitHub is gone. Let me check what happened. Hello. Hey, anyone here? Luffy, it's Dapa. Jaw up, screen up. Okay, now it's back. Just like, yeah. I don't need this dog actually. Yep. Also, actually, you can check my source code from here and you can like go along with me. But yeah, as of now, my source code that I pushed to my GitHub is not finished yet. I will put it later. Yeah, I just finished this one when I came here at the stage. So, yep. So when I go to my repository, you're going to notice that it's not complete yet. But the all thing is inside here in the anime pullers. So of course, this folder actually I create for justly ingest my data into MongoDB. But yep, as of now, I use this one for demonstration as well. So after I convert my data and insert and create the index for vector search, right? So I just need to create the search system. So in my file, you will notice that I have search.ts here. So I hope this file will explain how MongoDB search to you. Easier to understand. So here in the search process, what I have to do, I just retrieve the input from the users, and then I just convert this one to be the embedded representation as a numeric representations. And then I just search straightforwardly into MongoDB like this. So here, this is my input, and then it will search from the this collection anime list, and it will try to find for like 500 candidates that could have something like similar to what something that I'm searching for, and return for like up to 100 search results back to me. And just that, and it will returns the results of searchings. I will show you. Anyone here would like to search some cartoon? Do you have some cartoon in your mind you would like to search? Dragon Ball, right? Okay, let me try to search. So instead of I search Dragon Ball directly, I will search based on its synopsis. Like I may say, let me try. Give me a moment. So I just need to say it like this. Okay. So I just put what I need to searching for. I will search for like story about how do we call Goku? I mean like the type of the superhuman. How do we say? Super Saiyan. Okay, the story about Super Saiyan. How do you spell Saiyan? S-E-Y, right? S-A-I. S-A-I. Oh. And Y-A, right? Y-A-N. Saiyans. To correct 7 balls. Okay. Yeah, Dragon Balls. Awesome. Okay. I will share two like just small like this. Okay, let's try to see. Gonna think why? Because I remove this one. Yeah, I comment this one. Yep. I was there. Okay, now it's return like Dragon Ball, like this. I didn't include the jargon in my search at all. But I just talking about like something about like Super Saiyan, right? Or I would like to try something different, like story about like. Do you have some idea about the One Piece, right? Oh, I think Luffy is maybe quite too straightforward, so I'm gonna try like pirate, right? About pirate. I will accidentally like miss typo as well. Pirate to find the treasures. I never said about this one before, but let's see what I got from here. Not about One Piece at all. Oh, it's here. Yeah, it may be not a top result, but it's also included here as well. So this is what I can do from here. Before I end my section, I want to show you like how do I ingest my data and convert into vector representations. So you can go back. You can open my start producer actually. So because of I just do this demonstration this afternoon, so that means I need to ingest like thousands of anime into my computer directly. So instead, like just use for loop, I use the Kafka instead. So from here, I just pulling the data from my anime list, right? So if you go to this file, get anime, I just like get all anime and keep looping into like keep going to the next page and next page, and then I will send to the next step to embed my data. So after I got a bunch of data already, I just did the same thing as I have done with searchings. So I just convert it back to be like I just convert it into the vector search into the vector representations. And then I just insert it directly into my database. And just that, and it's done. So in this process, you may not able to see like the search UI at all, because this one will be on the back end part. So it's going to be about like how do we gonna convert my data, how we gonna search it. So yep, that's about the process. But from here, you may see the other file as well, because like previously I accidentally like insert the wrong data, and I also include the adults animate here as well. So I need to exclude it later on. Yeah, so it's quite complex here. I mean, the way of like I represent the source code here, but I hope you can understand and like get some idea about like how the vector search work here. Well, I will open the floor for you to like asking me like about like the process, or like need me to clarify something here. Anyone like, would like to ask me about this one? Yes. Okay, let me work with myself.
ขอบคุณค่ะ
Yes.
แบบว่า for when you embed the data to store in the database, does it need to be the same model that you use to search, or like if we decide to change the model, do we have to like redo the database?
Okay, awesome. That's a very good question. I also had the same question as you before. So, yep, of course, you need to use the same model to search. The same model as you store your data to search as well. And if you would like to change the model, yep, that's right. You need to, rebuild it once again, like what I have done here. So you will see that I have one file named Re-embedded. So, yep, because I changed my mind to change my data structures that I just embedded. So that means I need to start over again to ingest my data. That's right. Okay. Thank you so much for your question, by the way. Any questions? Yes.
Yeah, so like I think many of us like might not like know much about the tech embedding or something like that. Is there any advice on how to choose it? Which encoding model is suitable for what kind of search?
Okay.
Yeah.
Thank you so much. So that's also a good question as well. So actually, like the model, you need to do some like benchmarking as well, testing with your data, or maybe you need to read through the documentation, because it depends on like what kind of your data is it, what is your data language is. So you need to check on that. So for me, I used to use like Nomics because it's good at like both in Thai and English as well. And as I check on benchmarking, it had a good result. And in terms of performance to execute on my computer, it doesn't use much time to convert it. Yeah, that's right. Thank you so much for your question. Because we still have a time, right? I will try to start over 5 minutes, right? Oh, okay, I will try. So actually, I'm gonna try to create like the whole new project. And of course, disclaimer is could be fails. So let's try. So I just would like to show you some sample. If you go back to your home today, what you can do. First of all, you just go to MongoDB Atlas. Oops. Yep, my web page is not finished yet. So first of all, you just go to your MongoDB Atlas. Give me a second. Why we need to create a MongoDB first? Because we need to have the database to store data, right? So you just open your Atlas, MongoDB Atlas, and create your first cluster. Actually, in MongoDB, we have always free and forever free tiers without using the utility card at all. You just like create it separately. And then you got your cluster like this. And then we need to insert our data. As of now, we already got our cluster. Next step, we just need the connection string. So from here, you can choose any. So I will choose for like maybe shell. So you can try to connect to your database as well. And I need to change my usernames. So just need to check that my connection is valid. So just connect to your database. And it seems like it's not work. Oh, it's work. Awesome. So that means right now we already got our first cluster. Next step, you need to ingest your data. So to ingest your data, you need to ingest as like the vector set, right? So I will try to insert some random data. I will try to create a new file here. Let me create this one, demo ts, like this. And then I will try to insert the story of myself and my friends. So I will insert my names and about myself into the data. So I will start from me. Name, like job, and I will put my description here. So, or it thought that this is not the name. So I will use like nickname instead. So description will be like the man who working at MongoDB, lonely in Singapore. Yeah, I need to attack myself first. So sad, no? And my friends, usually, and my friends, is him, actually, visited me at 2 a.m. randomly. Yep, I put like this. And then I will try to add another data. I will pick my friends, maybe son, you. I will writing about you. So so this is my friend's name and descriptions. What should I describe about you? Okay, maybe like the man who was studying abroad, who was students in Japan, something like that. So actually, it's quite too small data actually. So, but I will try to show you like how vector search work here. So after you already got your data, you need to convert it, right? You just build your first converters. So from here on my computer, I already installed the Olama, the application that allow you to run your LM locally. So I already installed the package to connect to Olama directly like this. This is like my function to convert my data. So I will create other functions. Oh, มีที่วางไม้ไหม Okay, I will create one function here, like main, right? And then I will convert my data. So to convert data is very simple. You just looping it, and then just send it directly. Vectors. Await. And I will call this one. And as like the Copilot generate for me, so we need to JSON simplify it first and send it just only like the descriptions like that. And then you just put the data like here. Give me a moment. Next step, you just insert your data. So you need to connect to MongoDB first. So I will use my function that I already created. Connect DB, and it need to be of it.
And then I will insert it right away. Collection. Thank you, Copilot. And I just insert one like this. And of course, we need to
include the full document or original document as well. So we can use the object split to include the original data and then include the embedding here, right? And done. This is the first part of ingest the data. So let's see what it can be look like. I need to run the demo file. Right? Oh, main functions. Oh, yeah, that's right. Thank you so much. Yep, it should be on nickname. Yeah, nickname. All right. And yes. And it hopefully it's done. Okay, I think it's done because I didn't print out anything. Oh, and you can see my password library from here. Awesome. Yep, that's fine. So this one I just insert into my local Atlas actually. So for you just use the normal Atlas like the cloud versions. This one just insert to my local Atlas here. And when you see that we got a new. We should got new database here. No. Why? It's not appear here. Refresh database. Oh, it's here. Okay, I got a new collection here. Now you see that my data, my descriptions already convert to vectors, right? Next step, we need to search. So to search, we just build the search. So I will create another function here
for search. I will refer to my previous source code here. Async functions search, and I will put q as query here. And of course, we need to retrieve the input from q or like from parameters like this, and everything. Thank you, Copilot. You helped me a lot. So, yep. And then we just like send our input into generate appendix like this. And then what next? Just connect your MongoDB. And I think I can copy and paste. Okay, so we just use the aggregation function to people collections. And it will return to result. And don't forget to change your path as well. So now our path, we use embedding, right? Yep, we use embedding. This one. And one thing that we forgot, we need to create an index for vector search as well. We need to come back here and click create search index. And we just put our path for embeddings. And our model size is 768. And we're going to use the code size similarity functions. Done. Okay, now it's ready. Now everything looks already good. I will hide the embedding as well. I don't need to show it. And set to BLA. And console logs the result. Okay, I will show just only nickname, and I will remove the descriptions. All right, is the moment of truth. What error here? Let's see what I'm missing here. What I'm missing here? To array. Oh, I'm missing parenthesis here. And change this one to be search. Like this. And let's try to run this one. So I will type Japan students. Oh, I think that's too straightforward. Maybe like studying abroad. Let's see the result. Yep, we got sun first and followed by job.
Yay, okay, yay. Now time is running out, sorry.
Yep, thank you so much.
Yay.
That's all.
It's referee idea, not mine. Okay, say bye to Singapore, bye-bye, thank you.
Yep, okay.
Do you want to say any last words?
Oh no, I just saying, just try to use it. Yep, you can come back to check on my repository and try to deploy this one with your own MongoDB cluster. I mean MongoDB Atlas cluster. And if you would like to deploy your own MongoDB Atlas on your own machine, you just install this thing. You need to install something we call Atlas CLI. Once you install the Atlas CLI, you can deploy exactly the same Atlas, MongoDB Atlas cloud version on your computers. You just using Atlas followed by deployment and setup. If I remember correctly, setup type the dash local like this one. I'm not sure. You need to install two things: Atlas CLI and Docker. And after that, it will deploy something that's similar to MongoDB Atlas cloud versions. I forgot the parameters. So that means you can try to run your own MongoDB Atlas on your computer directly. And it will create a new MongoDB containers. Docker container which contains the MongoDB Atlas inside. And you can follow the step. And you got your own MongoDB Atlas on your computers. And enjoy. And happy hacking. Thank you so much.
Thank you. Thank you very much. Okay, so...
Okay.